Yeah, you can sit it right there. I'll collect them and reorganize them later. Yes, it should be right there on top. We're on. So, back one. So we had several steps yesterday. Now, our first kind of main step that we had was find a variable to eliminate. Our second one was to find an eliminator equation. Eliminate the variable. Repeat steps 1 and 3. Solve backwards. Now, you don't have to rewrite these steps out. I wrote these steps up yesterday. And for those of you who weren't here yesterday, there are steps that are given in the note sheets. I just don't like how they're worded. It's essentially, this is saying the exact same thing. I just like this wording better. It makes a little more sense. So we want to find a variable to eliminate. Find an eliminator equation, an equation to use to eliminate that variable. Eliminate the variable and then repeat steps 1 and 3. Because we saw yesterday, once we use the eliminator equation for the first one, we don't need it again. We don't need to find another one because we can just use the two equations that we get after step 3. And then we solve backwards. And these here are kind of the 5 main steps that we use to be able to solve these 3 variable systems of equations. So when we look at this one here, the first step was to find a variable to eliminate. So we'll use the top equation. So we can signify this as our eliminator equation. It's the one we're going to use to eliminate. Now we need to pick, are we going to eliminate x, y, or z first? I was with z or x to begin with. But I noticed something else that's interesting.
There's all 2's and the y?
Yeah. That'd be easier. Because we could do x or z. Either one of those is fine. Because 2 of them, the top 2, the z's are the same. And we would just need to multiply the eliminator equation by 4 to get that to be the same. That's pretty easy. X is the same way. We have the top and bottom are the same. And we would just need to use a multiple of 3 to get that one to be the same. But hey, 2y is already the same in all 3, so that might be even easier to use. Now, since the y's are already the same, we don't have to do anything with it. We can just put our eliminator equation right underneath both. So, let's start with the one on the left. Would we add these or subtract these from each other? Are the signs the same or opposite? Opposite, so we add. If it's opposite, we add. So when we add these together, 3x plus x is 2 plus negative 2, or 2 minus 2 is, just like we wanted, negative z plus z. Seven plus negative 11, or 7 minus 11. Negative 4. So wait a minute, over here I have 4x equals negative 4, don't I? I mean, we still have a variable, don't we? Wait, I just have 1. Let's just solve for x. So for our answer, negative 1. We're already 1/3 of the way done. That was kind of nice when it gives us that. So let's come over here. We opposite, so we add. And as we saw the other day, even if we do get the operation wrong, as long as we're making sure to actually perform it all the way through, it'll still tell us if it is right or wrong. So read, because I think you were the only one not here yesterday. What we're saying is if we subtracted 2 minus negative 2, well, negative makes a positive, so it'd be 2 plus 2 is 4. Well, we wanted y to cancel out to become 0, yes? So the operation is not subtraction, it would be addition. We can change it. Does that kind of make sense? Some textbooks have us use a multiplier of a negative 1 or 1 so that the signs are always the same and we always subtract. But I think it's easier just add or subtract. So we look at this here, negative x plus x. It's 0. X minus x is 0. 2y plus negative 2y, or 2y minus 2y is 4z plus z. Negative 9 plus negative 11 is negative, solve for z, yeah. So this worked out nicely. Now, really, once we got x for the 1, even if the other equation came out to x and z, well, I can plug the value of x in and solve for the value of z. And now, well, we just need to solve for the value of y. I'm going to erase this here to make a little bit of room. Which equation do we want to use? The first one, x minus 2y plus z equals negative 11. So we'll use this one here. We can't use the eliminator when eliminating, but we can use it when solving. So if we plug it in, we'd have negative 1 minus 2y plus negative 4 is equal to negative 11. Our x minus 2y plus z equals negative 11. Here, this would just be negative 1 minus 2y minus 4 equals negative 11. Our negative 1 and negative 4 would combine to become what? Negative 5. What's next? Add 5 to both sides. So these would cancel, telling us that negative 2y is equal to and last but not least, we would divide both sides by negative 2. So negative 1, 3, negative 4 is our solution to this here. Questions on this here? good with this here. Let's look at this one here. Okay, we can use the top one. And again, we're using the top one because, well, it's got 1, 1, 1. All the variables have 1 in front of it. As we saw yesterday, if I can pick an equation that has at least one variable with 1 in front of it, it's the easiest one to work with because I can change 1 into any number. Unlike if I picked 3x to eliminate it out, it's hard to turn 3x into 4x. I have to change both. So the least changing of more than one equation that we can do, the better, because it's less operations we have to use. So we'll take this as the Eliminator equation. Now, do we want to eliminate x, y, or z first? Z. So we can eliminate z first. So 4x plus 4y minus 4z equals negative 2. 3x plus 2y plus z equals 0. Now, because the z's are already the same, they have 1 in front of them. The sign, I don't really care, because we'll take care of that with our addition or subtraction. So we can go on and do this first. We'll worry about the other one here in a minute. So would we add these together or subtract them? Because the signs are opposite. So 3x plus x is? 2y plus y is? Z plus negative z. It cancels. And 0 plus negative 1 is negative 1. Okay. Now we do have to do some manipulating with the Eliminator equation because the z's are not the same. Now again, like I said yesterday, I'm going to write it below it because I don't have space to write it out to the side. For y'all, I would write it out to the side. So our x plus y minus z equals negative 1. So what do we need to multiply the entire equation by to get the z's to be the same? 4. We need to multiply both sides by 4. So we'll distribute the 4 all the way through. 4 times x would be plus minus equals and then we can take that equation and put it right under our other one. So we subtract. Well, 4x minus 4x cancels out at 0. 4y minus 4y. 4z minus negative 4z. Well, the negative and negative make a. So negative 4z plus 4z is negative 2 minus negative 4, or negative 2 plus 4 is, it is no solution because 0 is never equal to negative 2. And really what it's telling us that those two equations are parallel to each other. Those two planes are parallel to each other. So we will not have a point or line that all three share. There's no commonality between them. Well, any other questions on this here before we move on to the next one? Okay, let's look at the next one here. Okay. And we chose y because the y's are all 1. We good for the next step? So looking at the one on the left, would we add them together or subtract them from each other? Yeah, we're doing y's. If we're doing x or z, yes, we would subtract. Because for x, since they have the same sign, we would subtract for x. Since z's have the same sign, we would subtract. But since we're eliminating y, we're going to add. X plus x is? Negative y plus y is? 0. Z plus z is? 8 plus 8 is? 16. Over here we would subtract because the y's are the same. Specifically the y's. 2x minus x is just x. Y minus y is 2z minus z. Positive z. And 16 minus 8. 8. Now, I'm going to just go on and put this down. 2x plus 2z equals 16. Because no matter which one we pick, x or z, we're going to have to use the other equation. Because whenever we're having to get the variables to be the same, either x or z, we always want to go up. We don't want to go down. We don't want to make them smaller. And the reason for that is here it doesn't really matter because 2, 2, 16, everything is divisible by 2. But if we have some numbers that are even and some numbers that are odd, we can have fractions. Or even if not every number is divisible by the number that we need, we can end up with fractions. I try to avoid fractions because they're easier not to deal with if we don't have to. So going up, increasing something by a whole number will not provide fractions. But if I'm having to divide to make something smaller, I roll the dice on fractions. So it's easier to go up than it is to come back down. 1 and 1, 2 and 2. So we're going to go up here. So let's do x. So what do I need to multiply this whole thing by to get the x's to be the same? 2. Well, 2 times x is 2x. 2 times z is equal to 16. Since the signs are the same, we would subtract. 2x minus 2x is, like we wanted, 2z minus 2z. 16 minus 16. Infinitely many solutions. And we have this here. Okay. Now, I'm going to actually work this through with y'all so that you can kind of see how we could actually get the equation for infinitely many. So we have x and z were the last two that we ended up with, yes? I'm going to erase this here just to provide some room. I'm going to say x is the variable a. Because when we have infinitely many, we use a variable a. I use a to denote a variable for this here. And we can define the solution from it. And what we do is we come back, and I'll pick this one here. I said the value of x was a, yes? So a plus z equals 8. And so what I'm going to do is start dividing x or y and z by the value a. So here we can subtract z from both sides. Well, not z, sorry, because we want it in terms of a. A plus z equals 8. I would subtract a from both sides, which tells me z is equal to negative a plus 8. Now, if I want y, now I'll pick this one here. X minus y plus z is equal to 8. Well, we said x was a. Z is negative a plus 8. I think that'll just set y equals 16. Because a minus y minus a plus 8. Well, a and negative a cancel out. Subtract 8 from both sides, and, well, negative y is equal to 0, or y is 0. So really that there would be the equations that would satisfy any solution for these three equations here. So if we were to pick, let's be helpful if I get a little more room, so we can kind of see the whole, all three equations. Move these up. Zero's going with that. Now, Paris, give me a value for a. Yeah. 4. So if I plug 4 in, so 4, 0, here it would be negative 4 plus 8, which is 4. So if I did this right, this here should be a solution, and we can check it. So we can say in the first equation, 4 plus 0 plus 4 equals 8. Well, yeah, 4 plus 0 plus 4 is 8 is equal to 8. So if we check it in the next one, 4 minus 0 plus 4 equals 8. Well, again, that's still 8 equals 8. And the last one, we have 2 times 4 plus 0 plus 2 times 4 equals 16. Well, that's going to be 8 plus 8 is. So it gave us a point that did satisfy this equation. Reed, give me one. 37. 37, 0. And then this would be negative 37 plus 8 would be negative 29. So here we'll have 37 plus 0 minus 29 equals 8. Well, 37 minus 29 is 8. Minus 0 minus 29 equals 8. Well, just like the top one. And here we'll have 2 times 37 plus 0 plus 2 times negative 29 equals 16. Well, 2 times 37 is going to be 74 minus 58 equals 16. Well, this here would be 16 is equal to 16. So this point here works with all three equations. It is a solution that does work. Someone say they had another one? Yes. Okay. 1,347. 1,347, comma 0, comma 1,300 plus negative 1,339. So here we can say 1,347 plus 0 minus 1,339 equals 8. Well, the difference between these two is 8. 1,347 minus 0 minus 1,339 is equal to 8. Well, that's still 8 is equal to 8. Here we're going to have 2 times 1,347 plus 0 minus, well, plus 2 times negative 1,339 equals 16. So here, 4,962 minus 8,762 equals 16. Make sure, yep, because 8 would be, so 6 would give us that, 1. So it does work. So here, those values for A, we just set up an equation to essentially identify that line where all three intersect, or all three are in common. So for the most part, I'm just going to ask for infinitely many solutions because it's not that I don't think y'all can do this, but if we had chosen Z, it would have given us a different setup than this here. Or if we'd have solved for Z first instead of Y, eliminated Z first, then we could have picked Y and X, and there's so many different variations of this. It's easier for now to just say infinitely many. Now, we will get to a point where we can actually do these and get these pretty easily, and that will be tomorrow. So for now, we have this here, problems 3 through 5, 11, and 13 on page 38. And that is all we are doing for today.